Dear students, good morning, good afternoon, good evening. How are you? I hope best for you. I Mukesh Kumar welcomes you to online Mukesh Online Academy. आपका मुकेश ऑनलाइन एकेडमी में स्वागत है. And we are doing the science of class 10 from the NCERT book. And we are doing chapter 13, that is the magnetic effect of the current. Okay. We have already covered this chapter into the previous 8 videos, in which we covered about the different type of magnets, what is the magnetic field, what are the different magnetic field lines, magnetic field patterns. Okay, is the magnetic field due to the state current carrying conductors, magnetic Oersted experiment, and the coil. So many things we have done. And in the last video we did the magnetic field due to a current carrying coil. I hope you would have seen those videos. If you have not still seen, it is better to watch those videos before watching this video, because every video is in continuation of the previous one. Okay, because it is a full chapter that we are covering here. Okay, and one usual tip: just whenever you are watching any study related video from any person, okay, just make the key points, make the summary. Okay, it will help you to revise into the exam very quickly. Otherwise it becomes too much to revise, and I hope you must be doing that. Okay. And if you have any query, if you have any doubt, then you can always write to me on the WhatsApp or email. So we will be happy to solve your queries. And I hope you must be getting knowledge from my videos. Kindly share it with your friends, subscribe to it, and ask your friend to subscribe, and ask me for the notes free of cost. I'll send you the notes free of cost. Just give me the message on the WhatsApp or email. So I'll send you the notes of all the chapters free of cost. Okay. And what we are going to do in this video, the magnetic field due to a current carrying solenoid. So we will cover what is a solenoid, what is the magnetic field pattern of the solenoid, how do we find the direction, how does it behave like a bar magnet, what are the different uses of magnet solenoid, and what is the difference between a coil and solenoid. That we will cover into this video. So now let's do it. So in this video, we will do the magnetic field due to a current carrying solenoid. In the last video, we had studied about the current carrying circular loop. So just let us repeat it again. So suppose this is the wire, and if we just convert this in the form of a circle, then it becomes a loop. Okay. Now, what is the solenoid? Suppose this is the wire. Suppose this is a plastic, okay, circular cylinder, and now we just roll this wire in the circular form around this. That means now this is having the many circular loops. These many circular loops, this becomes a solenoid. Okay. Now suppose if I remove it, so it becomes a solenoid, as you can see here. Okay. So when we just wrap the wire in the form of the cylinder and its two ends are connected with the battery, then it becomes a solenoid. Okay. So I hope you understood it. So what is the solenoid? So solenoid means a coil of many circular turns wrapped in the form of the cylinder. That is called the solenoid. So now let's write it. So first of all, solenoid, what does it mean? That a coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder is called solenoid. I hope this is clear to you. And in Greek, it means as a channel. Okay. So a coil of many circular turns of the insulated copper wire wrapped closely in the shape of cylinder is called solenoid. So we can just see the like this. Suppose we are wrapping the wire in this form. This is the cylindrical form. Okay. This means the many circular turns are there, many coils are there. Now this wire is connected with battery. Okay. And then with the key, and then this end is joined with here. So this is called the solenoid. Okay. Now when current is passing through it, then it will first go like this. here, then will go 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 here. So the direction of current here will be this, then it will go into to this direction, then this direction. The same will be in the other coils also. Okay, and then finally it will come out and will come here as like this. So this is the solenoid. When the current flowing through it, it becomes a current carrying solenoid. So now let's know what is the magnetic field due to a current carrying solenoid. So the magnetic field due to a current carrying solenoid. Okay, see, let's make this solenoid again. This is the solenoid. Okay, and this is carrying the connected with the battery. Now when the current flows through it, then it will go just like above, as I drawn above. Okay, so what will happen inside the solenoid? The field lines will be the straight line like this. This is the field inside the solenoid. Okay, now when they come out of it, they will become the circular turns like the bar magnet, as we have just studied into the bar magnet. Okay, so you can see here that the field pattern of the solenoid is just like the bar magnet, the same type of field pattern that you have studied into the bar magnet also. Okay, so the question comes often, how does the solenoid behaves like a bar magnet? Okay, now you can see that inside the solenoid the field lines are parallel to each other. Why are they parallel to each other? Because when the field from every point on the coil is contributing to the field inside it, and which is the same field inside it, and every turn of this coil or solenoid will contributing to the same field inside it. So the inside the solenoid it becomes uniform because the same field is there. And as we know that if the uniform field is there, so that means it will be the parallel line. So that is why inside the solenoid there are the parallel lines. Okay, so number one, inside the solenoid the magnetic field lines are nearly straight and parallel to its axis. It indicates that magnetic field inside solenoid is same at all points, that is uniform. And the reason I told you that every point on this coil is contributing to the field inside it, and the same field is being contributed by the every coil, means the every loop. So that is why inside the solenoid it becomes uniform and it becomes the maximum also. Okay, and now as you can see that this current carrying solenoid is behaving like a bar magnet with having the two ends. This is, see, the direction we just covered by the clock face rule. So this end will behave as a south pole. Okay, because the direction from this space we are getting the clockwise direction, and this pole will behave as a north pole. Okay, so now that means the field lines will be from the north to south. The field line will be in this direction. Okay, so from here they will go to north to south, then it will come like this. So this is the direction of the magnetic field here. Okay, number two, a current carrying solenoid behaves like a bar magnet. How can we prove it? How can we write it? Number one, its magnetic field pattern is same as that of bar magnet. Okay, this is the first point that we can write here. Number two, its two ends behave like south and north pole, just like the bar magnet. Okay, number three, it has the directing property just like a bar magnet. It means that when suspended freely, it sets itself in NS direction. same as the bar magnet, just as a freely suspended bar magnet does. Okay. Now, fourth, it has the attracting property same as that of bar magnet. What is the meaning of it? Like pole repel each other and unlike pole attracts each other. Okay. If we bring the, suppose if near this south pole, then it will be attracted, and here if we bring the north pole, it will be attracted, and if we bring north pole here, then it will be repelled, and if we bring south pole here, then it will be of the another magnet, then it will be repelled. Okay. So this is how it behaves like a bar magnet. Okay. Its magnetic field pattern is same as that of the bar magnet. Two ends behave like a south pole. This is like south pole because here the current is flowing in the clockwise direction, and it will act as a north pole because here the current is flowing in from this space in the anti-clockwise direction. Okay. It has the directing property. That means when it is suspended freely, it will adjust into the north-south direction just as the bar magnet, and it has the attracting property just like the bar magnet, that like poles repel each other and unlike pole attract each other. Okay. Now, how do we find the direction of the magnetic field? How will we find the south and north pole here? So next is, now let's draw the diagram here. Okay. Now this is the better diagram for you. Now you can see this diagram. This pole is behaving like a south pole and this pole is behaving like a north pole. And this is the diagram to draw the magnetic field of the current carrying solenoid. Suppose if we keep the compass needle here, then it will show the deflection like this. And if we show if we just keep the compass needle here, then it will show the deflection in this direction. Okay. Now, how to find the direction of magnetic field? That means we have to find which pole is the south pole, which pole is the north pole. Then only we can find the direction of the magnetic field. As we know, in the bar magnet also the direction of magnetic field is from north to south. Okay. So for this we need to know which is the north pole and which is the south pole. And for this purpose we use the clock face rule. Okay. We use clock face rule for this purpose. Okay. So that means one end of solenoid means the current carrying solenoid. Just remember, when the current is flowing to it, that means the current carrying solenoid behaves as a south pole and other end as a north. Okay, so its two ends behaves like a poles. Okay, and we use the clock face rule for it. So as we know that clock face rule, what does it say? That if at the face, if the current is appear to be clockwise, then it will be a south pole, and the face in which the current appear to be anti-clockwise, then it will be a north pole. Okay, I hope this is clear to you. So we have learned what is the solenoid, what is the magnetic field pattern of the solenoid, and how do we find the direction of the magnetic field, means the two poles. And as we come to know which is the south pole and which is the north pole, then we can find the direction of the magnetic field from north to the south pole. So inside the solenoid, it will be from south to north pole, and outside the solenoid, it will be from the north to south pole. Okay, just like the bar magnet. Now we will just discuss what are the different factors on which the magnetic field due to a current carrying solenoid depends. Factors on which magnitude of magnetic field, means B, inside a solenoid depends. Okay, as we learned into the coil, then first of all it depends on the current. The same way here, the field will depend on the current. It is directly proportional to the current, means when the current increases, suppose if we increase the current through the battery, so definitely the magnetic field will, this solenoid will become much more stronger and the field will become much more stronger. Second thing, it depends on the number of turns per unit length. Okay, suppose if the number of turns are more, that means in the per unit length, like 1 centimeter. If 1 centimeter of the solenoid has more number of turns than the other solenoid, then the solenoid which is having the more number of turns in 1 centimeter, or 1 inch or 1 meter, whatever unit you take, will have the more stronger field. Okay. Now, the next thing, here one thing more comes, that if we just insert a soft iron core inside it, suppose had it been a soft iron core, suppose had it been a soft iron sheet, and if we wrap the wire around this soft iron sheet, then this magnetic field will become much more time. What is the reason? Because that soft iron core will also get magnetized, due to which the field will increase. Okay, so now let's write the points. Number 1, strength of current flowing through solenoid. That means B is directly proportional to I, where I is the electric current flowing through it. As we already know, the direct relation means when the current increases, the field will increase. When the current decreases, the field will also decrease. The second point is number of turns in the solenoid per unit of length. Okay, per unit of length means we can take either 1 centimeter or 1 inch. 1 unit we have to take. Okay, so that means B is directly proportional to N. So we have N is equal to N upon L. N means the total number of turns and the L means the length of solenoid. Okay, suppose if the length of solenoid 5 centimeter is given and there are total number of 100 turns, that means there in 1 centimeter there are 20 turns. Okay, so this is how we need to calculate the capital N. So where, and capital N is the number of turns per unit of length. I hope this is clear to you. We can take an example here. If 1 meter of if 1 meter solenoid has 200 turns of wire, while a half meter solenoid has 50 turns of wire. Okay, so first solenoid we have the n, small n equal to 200 because the 200 turns, and the length we have the 1 meter, that means 100 centimeter. So we can have the capital N equal to small n upon L, that means 200 upon 100, so that means 2 turns per centimeter. Okay, now in the second one we have the 50 turns and we have the L half meter means 50 centimeter. So capital N will be equal to small n upon capital N and small n upon L. Okay, then 50 upon 50, so that means 1 turn per centimeter. It means that the first will have the more magnetic field than the second one. Thus 1 meter long solenoid has a greater number of turns per unit centimeter. So first solenoid will have more magnetic. I hope this is clear to you. So this is how the number of turns determine the strength of the magnetic field in the solenoid. The third point I told you. What is the third point? The nature of the core material. Nature of core material. Core material means, suppose inside the solenoid, if we put some material like the iron bar, like soft iron bar, so that means the field will become much more time, because that soft iron bar will also get magnetized. So if a soft iron core is placed inside the hollow tube, the magnetic field due to the solenoid increases considerably. And what do we call this iron rod? Core. The iron rod is called core. Okay. What is the reason? Because iron core gets magnetized by induction. Because through induction means just you being in contact Okay, it gets magnetized, it acquires the magnetic properties. I hope this is clear to you. Now let's repeat what are the different factors on which the strength of the magnetic field depends. First is the strength of the current. If we increase the current, then field will increase. If we decrease the current, then field will decrease. Second is the number of turns in the solenoid. Here we are not taking the total number of turns, we are taking the number of turns per unit length. If the total number of turns are given and the length is given, then we will divide them, then we will come to the 1 unit. But remember, the unit should be same, either centimeter or inch or meter, it should be the same. Okay. So if there are more number of turns per unit length, that means the field strength will become much more. And the third factor is the nature of core material. Suppose in the solenoid, suppose this is the solenoid, and if we put this rod, suppose this is the iron rod, and if we put this iron rod inside the solenoid, then this field will become much more, because this iron rod will also get magnetized due to induction, and due to this it will increase a lot of time. Okay, the many number of times that this magnetic field will increase. I hope this is clear to you. Now next, the uses of solenoid. Next point we have uses of solenoid. What are the different use where it is used? Basically, suppose if we want to magnetize any magnetic material, like just we discussed about the iron core, then we can place inside the solenoid, then it will get magnetized. So number one, used to magnetize a piece of any magnetic material. Okay, this is the first use of the solenoid. Number two, we told you about the soft iron core. If we put the soft iron core, then it becomes a electromagnet. Okay, and it behave like a temporary magnet. The soft iron core of a coil behaves as a temporary magnet. Why temporary magnet? It will remain magnet, the soft iron core will remain magnet as long as the current is flowing through the solenoid. Once the current stops flowing through the solenoid, it will lose its magnetism. Okay, so behaves as a magnet as long as current is passed. Okay, now instead of iron core, soft iron means the pure form of iron. Instead of the soft iron, if we put the hard steel, means the iron which contains some other mixed like chromium into that, or like a carbon into that, it becomes a steel, then it will become a permanent magnet, because the steel has got the more retentivity. It can retain the magnetism got by the induction, okay, for the longer period of time. And the hard steel core inside the solenoid becomes a permanent magnet. I hope this is clear to you. So let's repeat the uses. First, it is used to magnetize a piece of any magnetic material. Second, the soft iron core of the coil behaves as a temporary magnet, and the hard steel core inside the solenoid becomes a permanent magnet. Okay. Now we have one question: how does a solenoid differ from a coil? Okay. Now we have learned both solenoid also. Now let's draw the diagram. See, this is the single turn. This is called the coil. Okay. And when we have so many turns, then it becomes a solenoid. So as you can see here, in the solenoid, the diameter is more, but the length is less. Length means the thickness of the wire. Okay. Suppose this is the coil. So this is the length, thickness of the wire. And this is only the diameter. So in the coil basically the diameter is more and the length is less. But in the solenoid, the length is more. You can see there is more length. Length is from here to here, but diameter is less than the length. Okay. So what is the first point? So its first point is length of coil is less than its diameter, and while the length of solenoid is more than its diameter. Okay, I hope this is clear to you. And second thing, as we just discussed above, the solenoid behaves like a bar magnet, while the coil behaves like a disc small magnet. It also has got the north and south poles, Solenoid has also got the north and south poles, but the magnetic field pattern of the solenoid is just like a bar magnet, and that is like a disc magnet. Okay, the solenoid behaves like a bar magnet, while loop, you can say coil, behaves like a two current carrying straight conductor flowing in opposite direction, means as a small disc magnet. I hope this is clear to you. So the length of coil is less than its diameter, while the length of the solenoid is more than its diameter, and the solenoid behaves like a bar magnet, while loop or coil behaves like the two current carrying straight conductors in which the current is flowing in opposite directions as a small disc magnet. I hope this question is clear to you. So students, today we have done what is the solenoid, how does it field pattern looks like, how does it behaves like a bar magnet, what are the different factors on which the magnetic field depends, okay, and how can we increase the strength of the solenoid, what are the different uses, and how does a solenoid differ from a coil. So in case of any doubt, you can always write to me, so we will be clear your doubt. Okay. So dear students, in the next video we will do about the electromagnet. Okay, what does the electromagnet means, what are the different uses of electromagnet, so what are the different shapes of the electromagnet, that we will do into the next video. Thank you so much for your watching. Write your comments about the video, any query, any doubt about the topic into the comment box, or you can write to me on the WhatsApp or email, so definitely we will be happy to solve your queries. Okay, and I hope you must be making the key points, you must be making the summary. Making the summary is good for your studies. Okay, it will help you revise into the exams, and I hope you must be getting knowledge from my videos. Kindly share it with your friends, subscribe to it, ask your friend to subscribe. Thank you so much.